already. So far, we've learned two methods for solving quadratic equations. You don't have to write this down, but so far we have solved quadratic equations in two ways. The first way we looked at is if we could make one side equal to 0 and then factor it, then we could find out what the two answers are. I'll call that way factoring. And the other method that we learned was if we had just one thing squared, then you could square root both sides. So how do we decide between the two different methods? When can you use one? When can you use the other? And now we're going to look at how you can change one from being one that you might think is factoring into one that you could square root both sides, is what we're going to be doing today, is whether or not you have something, the x being squared with no other x's, then you're going to square root both sides. So in both of these examples, do you see you have an x squared here, but you have no other x's? There's no, it's 2x squared, but it's not plus 3x or plus 5x. You just have an x squared. So then you could get the x squared by itself and square root both sides. In this second example here, there's the thing that's squared. The x is inside of it, but if we look in the rest of the equation, there are no other x's. So this could be one where you could get the thing that's squared all by itself and square root both sides. If your question looked like this, x squared minus 2x equals 8, where's the thing that's squared? Right now it's here. There is another x. So here's one where I would try to make one side equal to 0 and then factor it. And when you do that, this one happens to be x and x. 4 and 2 make 8, and the outside and the inside add together to give us -2. So generally, when we have one with an x squared and x, we're going to think factoring first. There's going to be some times, though, that even though it looks like you should try to factor it, it won't actually work to factor. So what we're going to learn today is a technique called completing the square. And I'll put this on YouTube so you can watch it later, but you don't need to write this down. But here's the idea. So we have a question that says solve for x. And it's x squared plus 5x plus 8 equals 0. No, I don't want it 5x. I'll make it an even nicer number. Let's go x squared plus 4x plus 8. That's a nice looking number. So we start with this and we think, oh, this is the factoring type. So we go to try to factor it, and we say x and x, because that gives us x squared. And then we think, well, what are two numbers that multiply to give us 8? Well, it could be 2 and 4. But then my outside is 4, my inside is 2. Does that ever make 4? No. So I try a different thing. Maybe I try 8 and 1. Now my outside is 1, my inside is 8. Does that ever make 4? No. So we're stuck here because no matter what we try, it can't be factored. So we tried to solve this with factoring, and it couldn't be factored. So this method, our factoring method, doesn't work. So we'd like to say, well, I'd like to square root both sides, but the only way the second thing works is if the x is inside something squared and there's no other x's. But right now, we have an x squared here, and we have another x. So it doesn't look like that method's going to work either. However, I'm going to show you something. What's x plus 2 squared? If we multiplied it out and we FOILed it, we would get x squared plus 4x plus 4. Okay? You see how that's very close to what we have here. We have plus 8, we don't have plus 4. So maybe if we could somehow rewrite this or rearrange it, it's going to help us. So what I'm going to do to start with is I'm going to say, well, this is the part that's the same. So I'm going to get that part by itself on one side of my equation. I'm going to move over the 8 to the other side by subtracting 8 on both sides. And right now, I'm going to leave a space here just so that I can write something in. What needs to be in that green space to get this? A plus 4. But if I add 4 to one side, what do I have to do to the other side to keep it the same? Add 4. And now I'm looking at my example and I want to change it just a bit. Are you okay with me changing my original question just a tiny bit? Yeah. Okay. I'm just going to change my original question from a plus 8 to a minus 8. Trust me, you still wouldn't be able to factor it. But it's just going to change this 8 to this side to a plus 8 instead of a minus 8. And if you are writing this down or later you're going to make notes, then it doesn't change your notes too much and you're not too mad at me. And I don't get 50,000 dislikes just because of that. Okay. At this point, what is x squared plus 4x plus 4? That's equal to x plus 2 squared. And on this side, 8 plus 4 is 12. Now, we've changed it so the only thing being squared is right here. And now we could use our second technique. Our second technique was once you get something squared, you get it by itself on one side, and then you can square root both sides. When you square root both sides, what do you have to remember? Plus or minus. When you square root both sides, you have to remember plus or minus. Then to solve for x, subtract 2 on both sides. And you get x is equal to negative 2 plus or minus the square root of 12. This is almost full marks. The only thing we have to remember here, we have to ask ourselves, can I simplify the square root of 12? Yes, because it's 4 times 3. So that's 2 root 3. This technique of changing something from something that can't be factored to something that has a square where you could square root, this technique is called completing the square. So we'll go, there is, in your own notes, there is an example here as well where they start with x squared plus 16x equals 6. You don't have the algebra tiles, I don't think, in your notes. But they have this completing the square example in your notes as well. Here's the one. This is the one that's in yours? Yeah.